Hello everyone, welcome to the part 4 of the video session on topic root locus. So in the previous 3 videos we have gone through step 1, 2 until step 7. So now step 8 is nothing but a combination of all the 7 steps. In the 7 steps we have calculated so many different values. So plotting all those values in form of a sketch or in form of a graph is called as root locus. So now we will again start from step 1. Again, this is our S plane where we are going to sketch the root locus. Again, we have 4 poles, right? At s is equal to 0, at s is equal to -1, at s is equal to -2, and at s is equal to -3. S is equal to 0, s is equal to -1, -2, and -3. We have no zeros. And then what we did, we identified the regions for no root locus and root locus. And then we found out that the centroid is at -1.5, right? So here we have a centroid at -1.5. Now we know that centroid is a point on the real axis where all the asymptotes are going to meet each other. So you are going to actually draw the asymptotes by taking centroid as reference. Here we have 4 asymptotes, right? 45 degree, that is first asymptote. Theta 1 is equal to 45 degree, and our second asymptote is theta 2 is equal to 135 degree, and our third asymptote is theta 3 is equal to 225 degree, and our fourth asymptote is theta 4 is equal to 315 degree. And you can observe here all the 4 asymptotes meet at a common point on the real axis, which is called as centroid. So now we have 2 breakaway points. Breakaway point B1 and the value is given here, you can observe that. And again we will have a breakaway point here, that is B2, and again that value is given here, B2. Similarly, the root locus intersects the imaginary axis at 2 points, I1, which is +1i, which we found out in step 6, and similarly here you have I2, which is -1i, which we also found out in step 6. So now we will come to the crux of the matter. Now we have to plot the movement of these 4 poles. So we will start at the pole s is equal to 0. Again, the pole at s is equal to 0 cannot move towards right. It is a no root locus region. It has to move towards left. So it will move towards left. Similarly, the pole at s is equal to -1 should move towards right. So since they are moving towards each other, they will meet at a common point, right? And that we have already calculated. It is a breakaway point B1, that is -0.381. At -0.381, both these poles are going to meet each other, and after meeting they should break away from each other, and the breaking away from real axis always happens at either +90 degree or -90 degree. So you can observe here, out of these two, one of the pole at breakaway point will break at +90 degree, and after breaking at an angle of +90 degree, it has to reach where there are no zero locations, so it has to reach infinity, right? But to reach infinity, it will take help of asymptote. Theta 1 is equal to 45 degrees. So you can observe it is going in the direction which is guided by asymptote theta 1 is equal to 45 degree, and it is approaching where? Infinity. Now similarly, here you have one more branch, right? So that will break away from real axis at -90 degree, and then it will approach infinity following the asymptote having an angle theta 4 is equal to 315 degree. Now here you can observe, very important, when it approaches infinity, it will cross the imaginary axis, yes or no? And that crossing of imaginary axis or the intersection with imaginary axis should happen at 1i. Again you can observe here, the branch which is following angle of asymptote 315 degree will also intersect the imaginary axis or will cross the imaginary axis, and that crossing or intersection should happen at -1 I. Now similarly we have a pole at s is equal to -2. It will move towards the left, it cannot move towards the right because it is a no root locus region. And how far it will move? Until breakaway point. Similarly we have a pole at s is equal to -3, it will move towards the right, and both of them will meet at breakaway point B2, and then again one of the branch will break away at +90 degree, and then it will follow the asymptote having angle theta 2 is equal to 135 degree approaching infinity. Similarly the other branch will break away at -90 degree and follow the asymptote having angle theta 2 is equal to 225 degree approaching infinity. So this is the complete sketch of root locus for the given transfer function. That is, root locus tells us how the poles of the system move around in the S-plane for different values of k. If we keep on changing the value of k, then the location of the pole is going to change. But how that is going to change, so that we will know by sketching the root locus. So now coming to the last step, inference on stability. So in this particular problem we can say that if the value of k is between 0 to 10, system will be stable, and when k is equal to 10, we saw in step 6, it will become marginally stable, and for k greater than 10, system will be unstable. That means here if the value of k is between 0 to 10, then all the poles will lie in the left hand side of the S-plane, and when k is equal to 10, some of the poles will, or here 2 poles will lie on the imaginary axis, and when k is greater than 10, these 2 poles will lie on the right hand side of the S-plane. So here you can actually make one important inference. The stability of the system purely depends on s is equal to 0 and s is equal to -1, because you can observe s is equal to -2 and s is equal to -3 for all values of k, they lie in the left hand side of the S-plane only. Yes, no? You can observe here they never cross over to the right hand side. The roots or the poles which are crossing over to the right hand side are s is equal to 0 and s is equal to -1. So depending on the value of k, these 2 poles will be either in the left hand side on the imaginary axis or on the right hand side. If the value of k is between 0 to 10, these 2 poles will be on the left hand side, and if the value of k is equal to 10, this will be on the imaginary axis, and if the value of k is greater than 10, this will be on the RHS, and based on that we can come to a conclusion that 0 to 10 stable, k is equal to 10 marginally stable, k is greater than 10 unstable. So these are the 9 steps which help us in investigating the stability of a given control system using root locus